Find the domain of these rational functions. When I hear the words rational functions, the first thing that I have in my mind is no zero in the denominator. All right, so no zero in the denominator. Let's take a look at the pink function on the left. I have f of x equals to a square root negative x plus 12. Denominator, I have x minus 7 and ln x minus 4. So for x minus 7, for this factor, you don't want x to be equal to 7, right? And then I will just write x minus 7 cannot equal to 0, then x cannot equal to 7. This is the first restriction. No 7. When you choose a value for x, there are restrictions. The first one is no 7. How about ln? So we know that ln of negative and also ln of zeros, they are undefined. So that means x minus 4 must be greater than 0 and x must be greater than 4. That is the second restriction. When you choose a value for x, cannot be 7, it must be greater than 4. And also, there is a hidden restriction in this type of problem. Do you know that ln1 is equals to 0? So let's put this in a different color. We know that ln1 is also equals to 0. We do not want ln1 in the denominator. So that means x minus 4, you don't want that to be equal to 1. Add 4 on both sides, you do not want x to be equals to 5. Okay, so that's it for the denominator. How about the numerator? The numerator is a square root. We know the square root of negative is undefined, right? Square root of negative is undefined. Square root of 0 is 0. Square root of positive is positive. So that means for the top, we want the negative x plus 12 be greater than or equal to 0. Greater than or equal to 0. It is okay to have a 0 in the numerator. So subtract 12 on both sides, and then you have negative 12. And then once you divide both sides by negative 1, so you divide by negative 1 and then you divide it by negative 1, right? To solve inequality, when you multiply or divide both sides by negative, you have to reverse the direction of the inequality symbol. So I do that immediately, and then you have x greater than or equal to 12. So that is the fourth restriction. And then the next step is we put all the restrictions on a number line. So let's draw a line. And then this is going to be a 4, a 5, a 7, and a 12. So it must be greater than 4. No 5, no 7. Skip 5, skip 7. But less than or equal to 12. So skip 5, skip 7. But less than or equal to 12. So that is the domain on a number line. Then can you tell me the interval? The first interval will be from 4 to 5, all parentheses, because not including 4, not including 5. And then from 5 to 7, also parentheses. And then from 7 to 12, we use a square bracket because x can be equal to 12. So this is the interval. And then this is the number line. You can also use inequality, so that will be x between 4 and 5, and then x between 5 and 7, and then the last one is from 7 to 12. Oh, no equal. From 7 less than x less than or equal to 12. So this is inequality. Either one is fine. Usually on my test, I ask all of them. Okay, so that is the first function. And then the next function is basically trying to answer a what if question. So what if I have a ln on top and then the square root on the bottom? So what happened? So first of all, this x right here, this x, I cannot allow a 0 in here. So this x cannot equal to 0. That is the first restriction. When that is 0, basically we are all done. All right, and then for the square root in the denominator, for the negative x plus 10, can we still do greater than or equal to 0? Can I still include a 0? No, because this is in the denominator, right? You cannot have a 0 in the denominator. So that means we have to erase the equal. So this is negative x greater than, subtract 10 on both sides, and then once you divide both sides by negative 1 or multiply both sides by divide or multiply both sides by negative, you have to reverse the inequality symbol from greater than to less than, and then this is x less than 10, my second restriction. And then how about the x plus 5? So the x plus 5, this one is just simply greater than 0. Okay, so greater than 0 because ln negative is undefined, ln 0 is undefined. So you have x greater than negative 5, and then that is your third restriction. Let me ask you another one. Should I do this? Should I do x plus 5 not equal to 1 because ln 1 is equals to 0? Should I take care of this? The answer is no. Even though you have ln1, so even though you have ln1 on top, that is fine. ln1 is 0. We have that in the numerator, so it is okay. So this is not necessary. So this is not necessary. So that will be not necessary because the ln is in the numerator. Okay, so ln is in the numerator. So now let's summarize all of them on one line. So I'm going to draw a line. And then I have greater than negative 5, less than 10. So I have greater than negative 5, less than 10, and then no 0, right? Skip the 0. So that will be a greater than negative 5, skip a 0, and then less than 10. We are not including any one of them. So this will be from negative 5 to 0, and then from 0 to 10. Okay, and then how about the inequality? So that will be negative 5 less than x less than 0, and then 0 less than x less than 10. So I include the number line, the interval, and the inequality. Okay, so that's it for this problem. If you like the way I explain domain, thumbs up, subscribe, and I will meet you all in the next video. Signing out.